Okay, hello, my dear. We are going to be doing trigonometry, the 3D shapes, right? So I'll start by giving you the background of this topic. Is it okay?
Okay.
All right. So I'll start by telling you about the right-angled triangle. All right,
Okay,
right-angled
sir.
triangle. You've seen this many times, heard of it, and talked about it many times. So draw a right-angled triangle right here. All right. There is the right-angled triangle, and we need to know how to label the right angle triangle, right?
Okay.
What name do we give to the side AC?
The hypotenuse.
Hypotenuse. And this one, if this is the angle,
The opposite.
the opposite. And this one, if the angle is this,
The adjacent.
the
The
adjacent,
adjacent.
right? Then
Mhm.
there are important things you need to know if you are dealing with a right angle triangle. Number one, it's the Pythagoras theorem. Do you know what this one says?
Yes.
Okay, so using the labels we have, it says hypotenuse squared is equals to the opposite squared plus the adjacent squared. You agree with me?
Yes.
Then number two, you need to know about SOHCAHTOA, right?
Yeah.
Okay. So if you are dealing with SOHCAHTOA, it gives you the connection between the sides and the angles. So we have sine theta equals to opposite over hypotenuse. You agree with me?
Yes.
And cos theta is equals to what?
Sorry, sir.
Cos theta is equals to what?
Okay, it's adjacent over hypotenuse.
It's adjacent over the
Yes, adjacent.
hypotenuse. Then tan theta,
It's opposite over
mhm,
adjacent.
over adjacent. Okay. So whenever you see a right angle triangle, and you know the existence of a right angle triangle by this angle being 90 degrees. Okay. One of the angles is 90 degrees. All right.
Yes.
But what if whatever you are given is not a right angled triangle? So we want to discuss what happens when you are dealing with non right angled triangles. Okay. We need to see what happens if what we are dealing with is not a right angle triangle. Okay.
Okay.
So whenever you see a non-right angle triangle, meaning that the shape you are looking at does not have any right angle on it, then you need to think of two things. The first one is the sine rule. Okay. And the second one is the cosine rule. Okay.
Okay.
So we are saying the minute you see a right angled triangle, you think of Pythagoras, you think of SOHCAHTOA. Agreed? Okay.
Okay.
But if what you are looking at is not a right angled triangle, then you think of the sine rule and the cosine rule. Okay.
Okay, sir.
So we'll start by having the sine rule here, and then we will discuss the cosine rule this side. Okay.
Okay.
So I'll draw a shape. Now, it's not a right angle triangle this time. It's just a triangle. Ugly, but it works. This is A, B, C. All right. Then
Yeah.
let's say this is theta, and let's say this angle is alpha. Let's say this angle is beta. Okay.
Okay.
Now, what sine rule says is that you see A, this one is opposite this angle. I'll I can use angle A. I can call this angle, which I labeled theta, I can call it A, right?
Yes.
All right. So we are saying you can have A over sine of angle A being equals to B over sine of B equals to C over sine of C. Okay.
Yes.
So if you are to follow the pattern here, we are just saying the side over the sine of the angle that it is opposite to. You understand?
Yes.
So sometimes it is also okay to start by writing angles on top to say sine A, then over small a. But if you do this, you have to do it for all the other ones. They have to start with the signs. You understand? You invert everything. Then it still remains true. Okay.
Okay.
So these are the important things you need to know on sine rule. Okay.
Okay.
You understand? And what does this mean? If
Yeah.
I have a C and the angle at C and I have the angle at B, I can find the side small b. You understand?
Yes.
You need three things for you to find the missing one. And depending on what you want to find, that's where you choose either the first one or the second one. You understand? Depending, if you want to find the side, it is easier to make the side the subject of formula from this one, which is the side on the numerator. You get it? You just multiply both sides by sine. Okay?
Okay.
Okay. Then the cosine rule, let's have it like that. So we have A, B, let me say B, then C, a small c this side. Now, so if I am using the angle theta this side, okay, this is important, pay attention. The
Okay.
cosine rule says A squared is equals to B squared, which is this one, okay, plus C squared, which is this one, all right, minus 2
Okay.
times BC, then cos of theta. Do you understand?
Okay.
All right.
Yes.
That's the cosine rule. And these things you are given in the formula sheet, they are provided for you. But if I say my angle is alpha, let's say the question gave me this angle, not theta, gave me alpha, right? Then this is important. C squared is equals to A squared plus B squared minus 2AB, then cos of alpha. You understand?
Yes.
So what is important is the side which is opposite the angle provided is always the one on the left-hand side. Then on the right, you find the other sides which are forming the angle. Like here for the first one, I'm using theta as my angle, right?
Yes.
So it starts by saying A squared equals to, then the sides that are forming the angles, it's B and C. Okay, so it's B squared plus C squared minus 2BC, then cos of the angle. If my angle is alpha, then C is the side which is opposite that angle. So it starts by saying C squared equals to. You understand? Then A and B are forming the angle. You agree?
Yes, sir.
If I am using, let's say, beta, this one, what will be the angle there? Or what will be
It
the
will
equation?
be uh b small b squared
Mm-hmm.
will be equal to a squared plus c squared
Mm-hmm.
minus 2ac
Mm-hmm.
cos theta.
Cos of beta. Good. Okay. So that's the important thing you need to understand. Agreed?
Yes, sir.
Is there anything you didn't understand from these two guys?
No.
So if a triangle is
I
non-right angled, then we think of sine rule and cosine rule. How to choose depends on the data provided. Do you see that for the cosine rule to work, you need an angle, two sides and an included angle to find the other side, right?
Yes.
So it depends on the data. That's how we choose. The same way when you are dealing with the right angle triangle, it depends on what they gave you. If they gave you two sides and they want the third one, Pythagoras does the job. But if you are given a mix of side and angle, the SOHCAHTOA will do the job because it is the one that mixes angles and sides. Agreed? It's a matter of choices now. Okay?
Mhm.
All
Yes,
right.
sir.
Now, can I show you now the exam type? Because the lesson is done. That's all we need. Okay, except we need to remember this one. Area of a triangle. Let me just add it here so that you remember, okay?
Okay.
Area of a triangle. All right. So, if you have a right angled triangle, like that, that's not a right angled triangle. Machine is not helping me now. Right angled triangle. Now, like this. So, if this is my height and this is my base, area is equals to half times base times perpendicular height. Agreed?
Yes.
But if you are given a triangle like this, okay, then you have the angle theta and you have the side A and side B, right? Area
Yes.
is equals to half A B sine theta, okay?
Okay.
This is another formula. All these are there in the formula sheet. It just depends on whether the data you have is enough. Do you have perpendicular height or you are given angles? You agree?
Okay, sir.
So with these things done, mentioned, that's the theory. Let's see the types of questions before this session ends, okay?
Okay.
So I will read. Are you able to see the question? Number 7.
Yes.
This is from 2018, paper 1, question 7. Now it says here, a pilot is flying in a helicopter at a point A, which is h meters directly above a point D on the ground. He notices a strange object at point B. The pilot determines that the angle of depression from A to B is 30 degrees. Now, remember when you are looking from above at this angle, the angle of your eye and the ground will be parallel, okay? Bear that in mind.
Yes.
Now,
Mhm.
the pilot determines that the angle of depression is 30 degrees. He also determines that the control room at point C is 3h meters from A and BAC equals to 2x. Points B, C, D are in the same horizontal plane. This is the scenario. So, I want to give you something also before we deal with this question. Normally, they will say a netball pole is provided, right?
Okay.
Now, I want to explain this part where they are saying points B, C, and D are on the same horizontal plane. Now, if this is a horizontal pole, a person who will be standing here will be at 90 degrees with the pole. Do you agree?
Yes.
A person who will also be standing here will also be at 90 degrees. That's the same thing, okay? It is always 90
Yes.
degrees to the pole. You agree?
Mm.
If you
Yeah.
played netball before. So this is what will be happening. They will all be at 90 degrees to the pole, right?
Yes.
So that's exactly what they are saying. Points B, C, and D are on the same horizontal plane. So they introduced right angled triangles here, right?
Yes.
But do you see that the angle D, the angle here, is not 90 degrees? It is bigger, okay?
Yes. Oh, yeah.
Now, looking at this diagram, we already said that this angle of that we are seeing with, it will be parallel to the ground. Agreed?
Yes.
Now, having agreed to that, it means we can also agree that this angle is 30 degrees. We are using the idea from Euclidean geometry, alternate angles. Are we together?
Yes.
We haven't seen the questions. We are just analyzing what we see here without pressure, right?
Yeah.
Looking at the diagram, I see a mix of right-angled triangles and non-right-angled triangles. For right-angled triangles, I think of two things. That is Pythagoras and SOHCAHTOA. For non-right-angled triangles, what do I think of?
The sine rule and the cosine rule.
The sine rule and the cosine rule. Very smart. Very good. Okay.
Okay.
Can I show you the question?
Yes, sir.
The first question says, determine distance AB in terms of h, right? The distance AB
Yeah.
in terms of h. So we want to create an equation that is in terms of h. That's our 7.1. So it is allowed to extract the piece of diagram that has the information you need. Do you see that they want the distance AB? I see AB is this one. And in terms of h, I see the, so do you see the right angle triangle we are using? It's ABD.
Yes.
So I can extract it and have it here on the side to say, I can just draw it this way, make things easy for me. And not ugly like that. Forgive me. Let's try something. Okay, let's see. All right. So I can say A, B, and D. Do you agree with me? 90 degrees here.
Yeah.
H is this side. Then we said here it's 30 degrees. Agreed?
Yes.
By alternate angles. Now, they want us to find the side AB, and I have an angle and I have one side. So, do you think we go to SOHCAHTOA or to Pythagoras theorem?
Here we can go to SOHCAHTOA.
SOHCAHTOA. Why? Because we have a side and an angle. SOHCAHTOA mixes,
Yes.
right?
Yeah.
Okay, good. Now, what name do we give to this side, which we label the H?
Is the opposite.
Is the opposite. And the side we want to find, what do we call it?
Is the hypotenuse.
The hypotenuse. From this, which one mixes the opposite and the hypotenuse?
Is the sine.
The sine. So we are saying sine of 30 is equals to, what is our opposite? H. Our hypotenuse? AB. Remember, we are asked to find the AB in terms of H. Agreed?
Yes.
So if I am to cross multiply here, in the end, I will have AB equals to H divided by sine 30. Do you agree with me?
I don't. Okay, so wait a minute.
Wait. Okay. AB will multiply sine 30. Agreed? Equals to H.
Yes.
Then I can divide
Yeah.
both sides by sine 30. Agreed now?
Yes.
Okay. So sine 30 and sine 30 will cancel. You follow?
Yeah.
All right. So my AB is now equals to, sorry, the right side is not supposed to be cancelled. There is no cancelling on the right. Okay.
Yeah. Yeah.
Okay. Now, so what remains? It's h over half, which reduces to AB is equals to 2h. Do you agree?
Yes.
So this is AB in terms of h. Your 2 marks are there. You agree?
Yeah.
All right. Done. Any issues here?
No.
We saw the question. We saw it is working with a right angle triangle. We remembered SOHCAHTOA and Pythagoras. We excluded Pythagoras because it didn't have data. We chose SOHCAHTOA. Everything was algebra. You see this?
Yes, sir.
Good. Then they are asking us about 7.2. On 7.2, they are saying show that the distance between the strange object at point B and the control room at point C is given by BC equals to. A question that says show that, it means this is our answer. Agreed?
Yes, sir.
All right. So we want to show, that's our job. We want to show that BC is equals to h square root of 25 minus 24 cos squared x. Okay.
Okay.
But the question you ask yourself that creates an equation is, how do I find BC? That's the actual question you want to answer, okay? How do I find BC? All right?
Okay.
So let's go to the diagram. Do you see where BC is? This is B, this is C. Okay?
Yes.
We got this side
Yeah.
to be 2h. Okay, that's it. We got this side to be 2h. And I am being asked about BC. So BC is attached to two triangles, BCD and BCA. Do you see that?
Yes.
But BCD does not have enough info. I don't have this side, I don't have this side, I don't have this angle. And it's a non-right angle triangle, so I cannot use sine or cosine for it, right?
Yes.
But if you choose A, B, C, do you see that A, B is labeled, A, C is labeled, and I'll be left with BC to find. The angle is given 2x there. You get it?
Yes, sir.
So I'm going to draw that triangle down here. Draw the triangle. I'll have my A, my B, and my C. And we said our AB is 2h and AC is given as 3h and the angle is 2x. That's what I'm extracting from this diagram. Do you see this?
Yes, sir.
With this type of data, this triangle, it's a non-right angle triangle, isn't it?
Yes.
Now, it means we are choosing between sine rule and cosine rule. You follow?
Yeah.
With this type of info, what do we choose?
Okay. Definitely the cosine rule.
The cosine rule, because if you choose sine, you want to find BC, you don't have enough angles, right?
Yes.
So it says BC squared equals to, because BC is the side opposite the angle, agreed?
Yes.
Exactly. So BC squared is equals to AB squared plus AC squared minus 2AB times AC, then cos of the angle 2x. Agreed?
Yes.
Now, our BC is what we want to find, so it remains BC squared. And our AB, do you see it's 2h?
Yes. It's 2h squared.
Then AC is 3h, right?
Yes.
2h multiplied by 3h, you follow?
Yes.
Then cos of 2x. Okay.
Okay.
Now, we start simplifying. And do you see, I'm very careful with the brackets because 2h, everything has to be squared. That's what I did there.
Yes.
So what will be the outcome of this? That's where common mistakes come in.
Okay. 4h squared.
Exactly. People normally forget to square the 2. Then plus, what do we get here? Faster.
9h squared.
9h squared minus. What is 2h times 3h? What do you get?
6h squared.
6h squared. Then times 2,
12.
12h squared. Then cos 2x. Are you with me?
Yes, sir.
Always when you're dealing with a proof that question, you need to check the direction where you are going. Do you see that I don't have cos 2x, but I have cos squared x, and I have a 25 and a 24 and an h outside. Do you get it?
Okay, yeah.
So the question you ask is, how do I change cos 2x to cos squared, right?
Yes.
Now, they are identities that you need to remember. Cos 2x can be written as cos squared x minus sine squared x, or 2 cos squared x minus 1 or 1 minus 2 sine squared x. These are identities for cos 2x. Do you know anything about these ones?
Yes, sir.
All right. Now, so again, do you see that we are in a position to choose again? We have three things, we need to choose one.
Yes.
What we choose depends on where we want to go. I see cos squared, there is no sine, right?
Yes.
So this one is out and this one is out. I choose this one, which is cos. Okay. Do you follow?
Yes, sir.
All right. So it means that my answer reduces to 4. Okay, what is 4h squared plus 9h squared?
Sorry, sir.
4h squared plus 9h squared.
13h squared.
13h squared. Then minus
Yes.
12h squared here. Now, check this out. I can do this. Cos 2x for now. Remember, it's still bc squared, right?
Yes.
I noticed something. I can do bc squared equals to, do you see there's a common factor here?
Yes.
What is it?
It's the h.
H squared, not h alone, right?
Okay, yes. H squared.
So I remain with 13 minus 12 cos 2x. Are you with me?
Yes.
Do you see if I want bc, I have to take square root on both sides?
Yeah.
Okay. It gets interesting now. Follow properly. If I leave you
Okay.
behind, you say, okay?
Okay.
Do you know that square root of AB is the same as square root of A times the square root of B?
Yes.
If you agree with that, it means it's the same as square root of h squared multiplied by the square root of 13, no need for bracket, but 13 minus 12 cos 2x. Do you see this?
Yes.
What is square root of h squared?
It's h.
It's h. Then square root of 13 minus 12 cos 2x. Do you follow?
Yes, sir.
But now we have our identities from this side, right? We can replace cos 2x with 2 cos squared x minus 1. Are you with me?
Yes.
Okay, so let's do that together. It means h square root of, then I have my 13 minus 12. Instead of writing cos 2x, we are going to replace with 2 cos squared x minus 1. Are you with me?
Yes.
Which means h square root of 13. What is my negative 12 times 2 cos squared x?
Sorry, sir.
Minus 12 times 2. What do you get?
Negative 24.
Negative 24. Then cos squared x, right?
Yes.
All right. Then what is negative 12 times negative 1? What do you get?
Plus 12.
Plus 12. All right. Then moving on, we have our BC equals to h. What is 13 plus 12, my friend?
It's 25.
25. Then minus 24 cos squared x, isn't it?
Yes.
What is it that we wanted to show? Let's check. We wanted to show that BC is equals to h square root of 25 minus 24 cos squared x. Is it the same we got?
Yes, sir.
So we nailed it. Then we collect our marks. We did it, right?
Yes.
So you see, it was a matter of choosing. I see right angle triangles. At this point, I see non-right angle triangle. When I see non-right angle triangle, there is sine rule, there is cosine rule. How do I choose? It depends on how the data is provided. Here, the cosine was only the one which was having enough data. We chose it, right?
Yes.
And we understood fairly well that the side which is opposite the given angle is the one that goes to the left. Hence, we created BC squared equals to, right?
Yeah.
We did correct substitution, expanded very well. Then we asked a question. What I want to show here is a cos squared, not cos 2x. What I wanted to show had a cos squared, not cos 2x. How does that happen?
Yes.
So we went to identities. Then from there, we saw three of them, three of the identities. Then the question was, which one do I choose? Again, it depended on where we wanted to go. Our answer was supposed to have cos squared, no sine, just cos. So we cancelled this one and the third one. We remained with the one which had cos alone, right?
Yes.
Then we came here. I saw a common factor. So all of this is algebra. The topic 3D shapes just introduced the formula. The rest became algebra as well as just the introduction of identities. Here, factorization, that's algebra. We took out h squared. Then this, it's rules of sets. What you're looking at, rules of sets. It's again algebra, right? It worked for us.
Yes.
Just to have our h outside because we are driving this to what we are seeing. It's a show that so we see the answer. Okay,
Okay.
done. So that's how we solved this. We later replaced the cos 2x with our identity. Okay,
Okay, sir.
any problems?
No,
No
this one is
problems, right?
okay.
Okay,
Yes.
gracias. It's all right. Thank you.